All right, class, now we're talking about factoring and solving quadratic equations. There are several different things that you can factor. One is factoring out a GCF, or greatest common factor. Here you're just looking for what number is the biggest number that every term in the polynomial is divisible by. So looking at your big numbers, 6 and 9 are both divisible by 3. Looking at your x's, you have an x squared and an x, so both numbers are divisible by x. So your GCF is 3x. You write that down. Then you do some dividing. 9 divided by 3 is 3. X squared divided by x is just x. Keep your minus sign, and then 6 divided by 3 is 2. X divided by x, they just cancel, and that would be your completely factored term. Do it again over here. 16 and 4 are both divisible by 4. X-wise, I have 6 x's and 4 x's, so that means that I could divide both terms by 4 x's, or x to the 4th. So my GCF is x to the 4th. I write that down. Now I divide. 16 divided by 4 is 4. X to the 6th divided by x to the 4th is x squared. And then over here, the 4's cancel, and the x to the 4ths cancel, so I just have a minus 1. Now, I do always want to check and see if this inside part can factor further. And this one actually can, which we'll talk about next. Dots. Remember, dots stands for the difference of two squares. Whenever you're factoring using dots, you have two terms, 1, 2. Those terms are being subtracted. One term will be a minus, one term will be a plus. You got to think to yourself, what times what gives you x squared? Well, that's just x times x. And then you want to think about what two numbers multiply to give you 25, and you want both of those numbers to be the same number. So this would be x minus 5, x plus 5. And that's how you factor, and you're done. Let's look over here. We're going for difference of two squares again. Again, 4 is a perfect square, and 49 is a perfect square, and so is x squared. So first, you want to think about what times what gives you 4. Well, that would be 2 and 2. What times what gives you x? That would be x and x. You'll have a minus and a plus. It doesn't really matter which order you put them in. And then you have 49. What times what gives you 49? That's 7 and 7. So that's your answer. Again, when you're factoring using dots, it's two terms. And those two terms are being subtracted. And you have perfect squares. So when you're factoring with three terms, that's when you're looking for numbers that multiply to give you the last one, but add up to give you the middle. So let's look at 32 for a second. If I look at 32 and I think about the number 32, I need to think of numbers that multiply to give me 32 before I do anything with the 12. So I can list all my factors, 2 and 16. 3 doesn't really work. I get a decimal. 32 and I could do 4 and 8. I can't do 6. I can't do 5. I can't do 7. And now I'm back at 8 again. So look at these two numbers. I want to know which one of these add up to give me 12. Well, 2 plus 16 is 18, so it's not that. But 8 and 4 is 12. So draw your parentheses. X times x gives you x squared. 4 times 8 gives you 32. And now you have to figure out your operations. Since 32 is positive and 12 is positive, it has to be a plus and a plus. Here, this problem was easy because the leading coefficient was 1. This problem has a GCF in it. So first, let's focus on our GCF. Our leading term is not 1, which makes life a little bit more complicated. They both all divide by 2. And we have an x cubed, an x squared, and an x. So everything is divisible by an x. So I have a 2x. And then I have now x squared, and divided by 2 is 5x. And then 12 divided by 2 is 6. So now I want to factor this inside part further, hopefully ending up in double parentheses with an x and an x. Numbers that multiply to 6, but when I add them up, I get 5. So numbers that multiply to 6 are 1 and 6 and 2 and 3. I'm adding up to give me positive 5. 1 plus 6 is 7, so that's not going to work. 3 plus 2 is 5, so I think that will work. Since it's positive 6, positive 5, we're going to have double positives here. And you just carry down the 2x. So this would be your final answer. This last one, we have to do a process known as MARF. MARF is when we can't factor out a GCF. Our leading term is not 1. So we multiply the first and last numbers. 3 times negative 5 is negative 15. Numbers that multiply to give me negative 15, but when I add them up, I get 2. Well, the only numbers that multiply to 15 are 3 and 5, or 15 and 1. But 15 and 1 are got no way going to give me 2. So think about it. One of these numbers needs to be a negative to multiply to give me a negative 15. Since the 2 is negative, the 5 is the bigger number, so that has to be my negative. So now I rewrite. I split the middle term up. 3x squared plus 3x minus 5x. So instead of negative 2x, I say plus 3x and 5x. And I just carry down this 5 and this 3x squared from the beginning. Now I group. I group these two together and I group these two together. And I take out a GCF. The GCF here is a 3x. So I have x left here because the 3's cancel. And then everything kind of cancels here, so I say I have a plus 1. Here, I want to factor out a negative 5 because I don't like it when my first number is negative. The 5's cancel. Negative 5 divided by negative 5 is a positive 1. Now, I know I've done MARF correctly if these two guys end up being exactly the same, which they are. So they make one of my factors. My other factor is made from the leftover stuff, the 3x and the minus 5. We're going to go ahead and skip factoring by grouping because we literally just did factoring by grouping right here. You just group those two and group those two. Now, you can always solve by factoring. Whenever you want to solve by factoring, you need to be equal to 0. So we'll go through one solve by factoring problem, and then we'll go through how to put it in your graphing calculator if you're not very comfortable with solving by graphing, or if you're not very comfortable with factoring. So let's look at this one. First we factor. Numbers that multiply to give me negative 18, but when I add them up, I get 7. So the numbers that multiply to 18 are 1 and 18, or 2 and 9. I want them to add up to give me negative 7. 2 and 9 are 7 apart. I need a negative 18. So if I make the 9 negative, that will multiply to give me negative 18, but add up to give me negative 7. Plus 2 minus 9. Then, once you get your factors, you set each factored part equal to 0 and solve it. So you'll move the 2 over, so x equals negative 2. And then you'll move the 9 over by adding it, so x equals 9. That's how you can algebraically find your answers. Now, if you're not comfortable with factoring, that's fine. All you have to do, let's look at this one. Let's say you didn't want to factor this one, you didn't know how. First, you get it equal to 0. So you have to move the 4x over to the other side. You can't subtract 4x and x squared. Now when you're here, pull up your graphing calculator, clear out anything that might be in there, and punch in your equation. X squared minus 4x. This only works when you make your equation equal to 0, like we've done here. Hit your graph button. This is a picture of the parabola. Your answers are wherever the graph crosses the x-axis. So the graph crosses the x-axis at 0 and at 1, 2, 3, 4. So you can say x equals 0 and x equals 4. So if you didn't want to factor, if you make your equation equal to 0, you can just pop it in your graphing calculator and look at the picture, reading where your graph crosses the x-axis. Either way, you should